Hello students, welcome to the Smart World, a school of complete learning. So, today we are going to read the second chapter, which is the sun, the moon and the earth. Okay. So, the first part which we will read is about the moon's motion. Moon's motion. Like the earth, the moon also has axial and orbital motions. The moon, while rotating around itself, revolves around the earth, and the earth revolves around the sun. As a result, though the moon does not revolve around the sun independently, indirectly, it makes revolutions around the sun. The time it takes to make one revolution around the earth and the one rotation around itself is the same. Okay, so that is why we constantly see one and the same side of the moon. You have to think that, like sunlight and moonlight, is there anything called the earth light? You haven't heard about the sunlight, the moonlight. Have you ever heard about earth light? If yes, where do you think it is found? Okay, so try it on activity. Carry out this activity on a playground, please. Select 3 students. Give them the roles of the sun, moon and the earth. Make the sun stand in the middle. Okay. Sun in the middle. It's not on the page here. Okay, keep going. Make the sun stand in the middle. Draw an elliptical orbit around the sun. Now, the student who has been given the role of the earth should rotate around himself from the west to east. Simultaneously, he should be revolving around the student who is the sun along the drawn orbit in the anti-clockwise direction. Now make sure that the student who is performing the role of the moon is also revolving around the one who is acting as the earth. Now draw a diagram of the whole activity in your notebook. Okay, this is the activity which you have to try, and you need only 3 students for this, nothing else, and just draw what you see on your notebook. For the geographical explanation, the moon's orbit of the revolution is also elliptical as that of the earth. Hence, the distance of the moon from the earth is not the same everywhere along its orbit while revolving. When it is the closest to the earth, it is said to be in perigee. When it is at the farthest, the position is called the apogee. So here you can see in the diagram, this is the earth, here is also the moon, here is also the moon. So the distance you see, what is perigee and what is apogee. Okay, so you have studied the phases of the moon before also. You know how it waxes from the new moon day to the full moon day, and how it wanes from the full moon to the new moon day, right? In the diagram also, waxing and waning moon is shown to you. Okay, so if you see figure 2.2, which shows the different phases of the moon, you have studied earlier too. It shows the relative position of the moon on both the quarters, the full moon and the new moon days with respect to the earth and the sun. So think about that. If figure 2.2 shows the position of the moon as seen from the space and as seen from the earth, how will you identify which are which? This is an interesting question if you think about it. Okay, so we see the phases of the moon in the sky. From the earth, there are illuminated portions of the moon. They become visible due to the sunlight reflected from the moon. While revolving around the earth, the moon is on the opposite side of the sun on a full moon day. Whereas on a new moon day, it is positioned between the sun and the earth. On the first and third quarter days, the moon, the earth and the sun make an angle at 90 degrees. At these positions, we see half the portion of illuminated moon. Hence, in the sky, it appears semicircular in shape. Eclipse. What is eclipse? The orbital path of the Earth and that of the moon are not the same in the place. So, what did we just read? The orbital path of the Earth and that of the moon are not in the same plane. The moon's revolutionary orbit makes an angle of about 5 degrees with that of the Earth, and as a result, the moon intersects the plane of the Earth's orbit twice during one revolution. On each new moon day, the lines joining the Earth and the Sun and the moon make an angle of 0 degree, whereas on each full moon day, this angle is a complete of 180 degree. Even so, the Sun, the Earth and the moon may not be in the one straight line and the same plane on every new moon or full moon day. Hence, eclipses do not occur on each new moon or full moon day. If you see in the figure 2.2 like this, okay, it shows the angle between the planes of the orbits. See, here it is. So, however, sometimes on a new moon day or a full moon day, the three fall in one line. The three, which three? The moon, the sun and the earth fall in the same one line and are in the same plane too. Okay, eclipses occur on such occasions. Eclipse may be solar or lunar. So, you have to think about, like, consider the relative positions of the sun, the moon and the earth on a new moon day and both the quarters. What will be the angle between the lines joining the earth and the moon as well as the earth and the sun? How many times will this angle be formed in the month? A question for you. Just think about it. What is solar eclipse? If the moon is between the sun and the earth, the shadow of the moon falls on the earth. At such a time, these three celestial objects are on the same plane and fall in one line. Hence, the place on the earth where the moon's shadow falls experiences a solar eclipse. This shadow is of the two types. The central portion of the shadow is darker and the periphery is light. In the area of dark shadow of the earth, on the earth, the sun becomes completely invisible. This condition is known as total solar eclipse. However, during the same period at the places where the shadow is lighter, the sun disk appears partially covered. This condition is described as partial solar eclipse. If you see in figure 2.5, you will be able to note this. See the earth, the sun, yes, the moon, and these two figures, total solar eclipse and partial solar eclipse. This is complete black and this is partially black. Okay, so back to the page 4. It is total solar eclipse is seen in a very limited region of the earth. See, here it is also saying the total solar eclipse is seen in a very limited region of the earth, like this. Okay, so next is, sometimes the moon is in apogee position. This means it is at its farthest from the earth. As a result, the deep shadow of the moon is cast in space and does not reach the earth. From a very small region of the earth, only an illuminated edge of the sun disk is seen in the form of a ring. This is called annual eclipse. Annular eclipse is a rare phenomenon. So here is an activity for you. Take a ball of clay or mud and keep it at the center of the table. Now fix a pencil vertically in the clay ball in such a way that its sharp ends points upward. Like in this activity, it has kept the clay or the mud ball in between and set a pencil like this in the middle of this, so that the जो sharp वाला side होता है it faces upward. Okay, now fix a small plastic or sponge ball on the sharp end of the pencil. Draw a circle along the midline of the ball. Let this ball be your moon. Think it to be your moon. Suppose you have to suppose this thing. Now place a large plastic or rubber ball at the distance of 10 to 15 centimeters from this moon. Let this larger ball be Earth. Draw a circle along the midline of this ball too using a pencil in the center. Let this be the equator. Now keep the ball steady using a rubber or a cloth ring. Arrange the ball representing the earth and the moon in such a way that the circles drawn on the moon will be in the plane of the equator of earth. Take a torch, which will be your sun. Hold it at a distance of about 30 centimeters from the moon. Direct the light beam of the moon as in the figure 2.7. Where is 2.7? Okay, it's up. Here it is, 2.7. Okay, like this. Now observe the shadow of the smaller ball on the earth to understand how solar eclipse occurs. The next is lunar eclipse. What is lunar eclipse? A lunar eclipse occurs when the moon enters the shadow of the earth while revolving around the sun around it. At this time, it is necessary that the earth is between the sun and the moon and all the three of them are in the same plane. On a full moon day, the moon's path of revolution passes through the thick shadow of the earth. If the moon is totally hidden within the shadow, we see a total lunar eclipse, and if only a part of the moon is in the shadow, we see a partial lunar eclipse, as we can see in the figure 2.8. See, partial lunar eclipse. Okay, now another activity is for you. Arrange the materials used for the solar eclipse demonstration earlier, as you can see in figure 2.9, and try to understand how a lunar eclipse occurs. Okay, see how that occurs. Now you have to use your brain power to answer some questions. Okay, so here your question goes. First is, on the day of solar eclipse, in which part of the earth will not be seen? Next is, can we see total and annular solar eclipse on the same occasion? The third is, why is an annular lunar eclipse not seen? Why? Which eclipse will you see from the moon? And the last but not the least is, why are solar eclipses caused by the other planets not seen from Earth? There is another question for you which you have to think about. It is, when solar eclipses do not occur on a new moon day, does it mean that the moon does not have any shadow at all? Think about it. Okay, so now read about the characteristics of solar eclipse. First is that a solar eclipse occurs on a new moon day, but not on every new moon day. Okay. Second is, if and only if the sun, the moon and the earth are in the same plane and fall in the one line, the solar eclipse occurs. The maximum duration of a total solar eclipse is 7 minutes and 20 seconds. That is complete of 440 seconds. Now let's read about the characteristics of lunar eclipse. A lunar eclipse occurs on a full moon day, but not on every full moon day. It is opposite to the solar eclipse, if you notice it. A lunar eclipse occurs if and only if the sun, moon and the earth are in the same plane and fall in one line. The maximum duration of a total lunar eclipse is 107 minutes. A huge time. Eclipse, an astronomical event. Okay, a solar eclipse or the lunar eclipse is just an astronomical event. There is nothing auspicious or inauspicious about these events. It is just a result of the sun, the moon, and the earth being in specific positions. There is a lot of curiosity about eclipse because an eclipse is not a regular occurrence. For scientists working in the field of astronomy, eclipse and particularly total or annular eclipse, social eclipse, present great opportunities for studies. Scientists from all over the world make it a point to visit the locations where such events are going to occur. They carry out elaborate studies of eclipse conditions. Always remember, children, while observing a solar eclipse, it is necessary to view the sun disk through dark glasses or special goggles made for that purpose. Otherwise, the intense light of the sun can be harmful to your naked eyes. So, during the period of the solar eclipse, a large number of birds and animals get confused due to the untimely darkness that sets in. As this is an event that does not suit their biological clock, their response to the event is so unusual. Try to observe the responses of the birds and the animals at the same time of such events and record your observations. Do you know about occultation and transit? Like eclipse, some other specific conditions occur with the reference to the sun or the moon. These are called occultation and transit respectively. Occultation occurs with reference to the moon, whereas transit is associated with the sun. So, what is occultation? This is a typical event occurring in space. The moon revolves around the earth. While doing so, it obscures a star or a planet, and that celestial body appears to hide behind the moon. This is called occultation. The total solar eclipse is actually a kind of occultation, and during this, the sun disk gets hidden completely because of the moon. And what is transit? If an inner planet like Mercury or Venus comes in between the line of the earth and the sun, a transit occurs. At that time, a small dot appears to move across the sun disk. Transit is a type of solar eclipse. You can see this in figure 2.10 also. Okay. So, next, here comes your exercise. Okay, so first question is to correct the wrong statements and write down the correct ones. So, children, you will be doing this and I will be asking you for the answers. Okay, so the first is the moon revolves around the sun. The second is on a full moon day, the moon, the sun, and the earth are positioned in this sequence. This sequence means the first is the moon, the second is the sun, and the third is the earth on a full moon day. Third is the revolutionary orbits of the earth and the moon are in the same plane. Next is in one revolution of the moon, its orbit intersects the earth's orbit only once. The fifth is it is alright to observe a solar eclipse without protecting the eyes. And the last, an annular solar eclipse occurs when the moon is in the perigee position. So, children, in these 6 sentences, you have to find out the wrong ones and correct them in your notebooks. Okay. Second question is about selecting the correct option. Okay. It's about solar eclipse. So, here are the three options. I think in these you are given with the position, like the white one is the moon, the greenish or the yellowish is the sun, and the third one which is blue in shade is earth. Okay, so you have to find out which one is correct in the position manner of the sun, moon, and the earth. Okay, Like in the first option, it is like the moon, then the sun, and then the earth. In the second option, it is like first the earth, the moon, and then the sun. And in the third, it is completely a different. First is the sun, the earth, and then the moon. So you have to find in during solar eclipse which option is the correct for the positions of these three. Next question is the shape of sun disk at the time of annular solar eclipse. What is the shape of the sun? You have to find this. Third is apogee position of the moon. What is the apogee position of the moon? What is apogee position? You have to mark a tick on the right option. Okay, third question is to complete the following table. Here the details you are given to you. Next column is for the lunar eclipse and next for the solar eclipse. Okay, phase of the moon. What is the phase of the moon during the lunar eclipse, and during the solar eclipse it is given to you. Next is sequence. So what is the sequence of during the solar eclipse, the type of eclipse during the lunar and the solar, and the maximum duration of total eclipse in the lunar and the solar. Okay, the fourth question is draw and label the diagram. You have to draw and label the diagram for total and partial solar eclipse and total and partial lunar eclipse. Fifth question, you have to answer the following questions. First is why do the sun, the moon, and the earth not lie in one and the same line on every full moon and new moon day? Second is when total solar eclipse occurs, why it is partial eclipse also seen from the earth? Here are questions for you which are interesting. Third is suggest measures that can be taken to eradicate the superstitions related to the eclipse. Fourth is what precautions should we take while observing a solar eclipse, and what types of solar eclipse will occur in perigee conditions. Okay, so these are the 5 questions for you which you have to answer. So there are some activities also. First is to collect paper cuttings about eclipse and paste them in your notebook. Next is to write a note on an eclipse that you have seen. And the final is using the internet, panchanga and calendar, collect information about the eclipse that are likely to occur this year. So this was the complete chapter about the sun, the moon and the earth. Just go through the chapter once or twice or thrice until you don't until आपको सारा समझ आ जाता है, and try to find out the answers for these exercises. Okay, all the best. Thank you.